Yeah, so some guidelines for the virtual meetup. Keep a check on your mic and your video. I mean, let's not disturb the speaker. And make sure you're like writing down your questions in the chat sections. We'll get back to all of them. If you all want to ask any question, you can just raise a hand or something like that, and or maybe we can have a Q&A session at the end as well. And also, yeah, do send us your feedback. I think we can get started. We have quite a lot of members now. So the agenda for today's session will just begin with the introduction, with the speakers, the audience and all. And then we'll just deep dive into the RTF architecture with Basim. And in the end, we'll be having a trivia quiz wherein whoever wins the quiz will be getting a training voucher from Mulesoft. So you're actually getting the and not the in-person, the virtual training vouchers from Mulesoft. So you can opt for any of the training provided by Mulesoft, and it will be given by the Mulesoft trainers. And then we can just have some chit chat, networking time, and all like we have in person meetup as well. So the next thing being the organizers. So it's myself and Terry Lockwood. So Terry is currently busy today, so I'll be the only one. And to introduce myself, I'm a Mulesoft ambassador and meetup leader for Manchester, London, and Mumbai region. I've been into Mulesoft for almost 4+ years. I'm a senior software engineer at EPAM Systems, and into technical stuff like writing blogs, sessions, trainings, meetups, and all these things. Okay. So if anyone is new to the Mulesoft meetups and would like to introduce themselves, maybe you can just get started. Feel free to do that in the chat sections, or maybe you can just unmute yourself as well.
Hello everyone. I'm Nagarjun. I'm not new to Mulesoft community, but had not been attending. I've not attended much of meetups, so yeah, I just wanted to introduce myself. And good to see Bassem. Had worked with Bassem long ago, so I just thought I'll attend this meetup once and see how this goes. Yeah.
That's nice. Thanks for joining.
Thank you.
Anyone else would like to speak up?
Hello all, this is Suraj here. So I am first time joining this Manchester meetup. I join other meetups regularly, but Manchester is the first one. So I'm a solution architect at Western Union, and I'm hoping to learn the RTF here.
That's nice. This is my first one as well for the Manchester. So the next thing being, important announcements by Mulesoft. So recently they have released the event-driven API, event-driven architectures API. I mean, it supports the event-driven architecture. I can just show you guys as well. I mean, earlier it wasn't supported. So currently it's only supporting the design and the publish phase, which is like the API designer and the endpoint exchange. Maybe y'all can just read more about it. I'll be sharing all the links as well in the chat section in some time. And the next thing being, there is a Mulesoft hackathon coming on for the 2021 thing. You all can register yourself, submit your projects and all. It's still open. The entries are open. If you all need any support and all, there is a team helping out others. There are mentors who are mentoring if you need some help. So do participate for the same as well. And as you all know, the Mulesoft community is growing, and there is a lot of requirement for mentors and all for the mentees, of course. So if you all wish to become a Mulesoft mentor, and if you want to contribute to the community, you all can sign up as a mentor as well. I'll be sharing this links as well with you all. And this is a calendar subscription link, which is like if you all just subscribe to this calendar, you'll be getting updates regarding all the Mulesoft meetups happening all over the world. So that's really nice. I mean, even I get updates. Like if you find topic interesting, you all can directly RSVP for the event. So after this, about our speaker, Basim. So he's an experienced guy. I mean, he's having 16+ years of experience. He's a senior solution architect at EPAM Systems. And maybe I would like, from here on, I would just hand it over to him, and he can just introduce himself and maybe take on from here. Basim?
Yeah, sure. Hello, everyone. Thank you for joining my my first meetup. Hope you will learn something new today. As Akshata mentioned, I'm senior solution architect at EPAM based in London. My skills and expertise in application integration, enterprise application architecture, delivering solution architecture based on microservice architecture, service-oriented architecture. I'm certified architect, Cloud Hub, AWS professional architecture, and Google Cloud architecture. Yeah, this is a really basic introduction about my skills and my expertise. So let's start talking today about RTF. I'm going to disable my camera, just make sure my streaming is good, and then I will share my screen. Okay. So the agenda for today is we will discuss the deployment strategy of Mulesoft, which basically is different option for Mulesoft customers. Mulesoft gives some features for different customers so they can have their own deployment strategy. We'll talk about Runtime Fabric operating models. There are different flavors for Runtime Fabric. Again, Mulesoft gave us different options to deploy our Runtime Fabric. We'll talk about Runtime Fabric in AWS architecture. Actually, we talk a lot about EKS architecture since this type of operating models, it needs some skills and some expertise with EKS. So we'll dig some time talking about the EKS architecture and how RTF will integrate with the EKS and all of these components. We talk about advanced concept of RTF, we talk about clustering, RTF, security of RTF, logging, monitoring, and all of this good stuff. And last, we'll talk about the RTF component needed for development application, some sort of object store, and how we can accommodate object store in RTF, and what type of object store implementation RTF. Talk about clustering as well, if of RTF nodes in RTF cluster. Okay. So we'll start by Mulesoft deployment strategy. Most of us are aware about this type of different control plane and runtime plane. So when we talk about control plane here, we talk about that some tools Mulesoft give us to control our runtime plane. Again, runtime plane is some sort of where we host our application. So some customer, they host their application Cloud Hub. Cloud Hub is different style, so we can host our application, we can run our application there. We don't need any sort of machine to be hosted on premise, so we can utilize Cloud Hub to deploy our applications there. Or maybe we can have our infrastructure in AWS or Google or whatever cloud architecture. We can host our application as well, or maybe we can have our own servers on premise. So this is all different type of flavors we can install or run or deploy our application in runtime. In order to control our application, and when we're talking about controlling here, which means, we're talking about starting by design phase, which is we starting by writing our RAML specifications, then we publish our RAML specification to Exchange to have some sort of assets. We can query assets from there. We can discover assets, and then from there, a management center as well. So we can enforce security over API. We deployed in our runtime plane through API manager. We have runtime manager. We'll talk about all of this later on, but in general, we have control plane and we have runtime plane. The control plane and runtime plane, the first style is to have control plane and runtime plane over Cloud Hub, which means we hosted all of component for control plane in Anypoint platform, and then the runtime plane as well will be deployed in Cloud Hub as a worker. So the customer at this point doesn't need to provision anything on his side or his premise, doesn't need to do anything, just to log in, and he can control and deploy his application in Cloud Hub. The second flavor is the on-prem. So some customers say, okay, maybe in order to decrease the budget of running our services over Cloud Hub, maybe we can provision some servers in on-prem, and then we will utilize Mulesoft to control or to secure or to manage this API from Mulesoft. So we split here the infrastructure between Cloud Hub as a Mulesoft control plane hosted and the customer hosted runtime plane. So at this point, the customer will install Mule servers, and each Mule servers will be basically runtime of Mule, and then we can host different application on the runtime of Mule. This type of infrastructure, or this type of architecture, it is not friendly with microservice architecture. As you see, it's one server, different application. But again, it is different flavor. If some customer prefer to go ahead with this type of deployment, it's up to them. And today we talk about our Runtime Fabric. So Runtime Fabric, basically, if you are targeting microservice architecture and all of this stuff, you have your own AWS Kubernetes cluster or Google cluster or Azure cluster. You can, Mulesoft still can support you to deploy your application over this cluster. So it gives you the runtime here as a runtime control plane, a runtime plane, sorry, and then the control plane will be still with Mulesoft. So you deploy all of your application on, let's say, over your AWS, and then you can control this application. You can deploy the application. You can enforce security. You can do all of this stuff from Cloud Hub control plane. This is what we're targeting today, and we'll show this in more detail later on. Some customers say, okay, because of some sort of security, some sort of budget, maybe we can host the control plane and runtime plane in private cloud. So basically, Mulesoft still can support them. Mulesoft will install the control plane and the runtime plane in the customer hosted infrastructure. Since we're talking about RTF today, RTF has different flavor. So we can have RTF on bare metal, which means we don't need any Kubernetes cluster at this point. The customer, we start asking customer how many nodes we are targeting at this point. So we say, okay, let's give us 6 servers, and then we decide how many worker or nodes we can provision here, how many master nodes, or we call it controller nodes, and then we have the control plane over Cloud Hub. As you see here, at this point, some customers prefer this type of operating models because they don't need to have any Kubernetes expertise, since it's everything, it's Mulesoft infrastructure. So customers give us a machine, and then we install everything for them. They don't need some sort of Kubernetes expertise. This type of installment, it can be supported over cloud or on premise. As it mentioned here, all of component, it will be bundled together, some sort of like Docker, Kubernetes, everything is optimized to work efficiently for RTF infrastructure for VM bare metal. Different flavor of RTF is to some customers, they have their own Kubernetes cluster over AWS or Google or Azure, and they say, okay, we already have our own infrastructure. We just need to install our Mule application over this infrastructure. How Mulesoft can support them? So Mulesoft still can support them. So at this point, what we need exactly is to empty Kubernetes cluster, and then we take it from there. Mulesoft will install all of Runtime Fabric component in this cluster. We will do this later as well. And what we need at this point is, as you see, it is shared responsibility. Basically, we need a Kubernetes cluster to be ready for us to provision our RTF. So we need some sort of network to be ready, subnets to be ready, nodes to be ready, the cluster itself to be ready, and we just need to install the RTF there. We'll go over all of this exercise in the demo as well, installment of RTF in AWS EKS cluster. As we said, this type of model is, we call it shared responsibility model. What does it mean, shared responsibility? Is Mulesoft will provide support only for Fabric component for runtime servers of Mule for deployment itself. And the Kubernetes administrator, which is from your enterprise, will create and configure the EKS cluster or GKS cluster, will configure the ingress controller, configure logs and matrices, configure container runtime and network. We will do all of these steps later on in the demo, so don't be worried about all of this concept. We'll discover them in more detail later on. So we understand now the bare metal and self-managed Kubernetes. As we said, the bare metal is, I don't have really Kubernetes expertise in my enterprise. I give you some machines, you provision your RTF there, and you do everything by your own. Or, I mean, Mulesoft will do everything for yourself. So the difference between make your Kubernetes and having everything from Mulesoft is the first flavor is shared responsibility. So you need to provision your own cluster, and Mulesoft will take it from there. The second one, you just give me the machine, empty machine, I do it for you. I have the package, I install everything for you. Linux distribution, it's supported for EKS or cloud. For Runtime Fabric bare metal, we will install, or Cloud Hub or Mulesoft will install Red Hat and CentOS. It's supported only for these two operating systems. For auto-scaling features for Runtime Fabric on cloud, it's supporting by using the cloud itself. We will talk about this later on, the auto-scalability in EKS. We'll discover what type of feature Mulesoft is missing at this point. But again, as you see here, is the auto-scaling features of the node. We're talking about node, we don't talk about the pod. It's still supported by cloud infrastructure. For Runtime Fabric, since it is bare metal, we don't have this type of auto-scaling feature. So basically, if you want to add something, you must add it manually by yourself, because you need to provision a new machine at this point. The log forwarding, it's here. It's you provision your own log forward. We'll do this again. For the bare metal, it's included. Again, the internal, it's included for Runtime Fabric on bare metal. Again, if you look here, it's internal load balancer. If we talk about external load balancer, you still need to provision this for bare metal. I'm not going to talk a lot about bare metal today, but as you see, this is a high-level comparison between self-managed Kubernetes and bare metal RTF infrastructure. So let's move on. So in very high level, what the big picture is. From your software perspective, you develop your application as a developer. You push your assets to Exchange through CI/CD process, and then Mulesoft or Cloud Hub will take it from there. You have a deployment process. You have deployment GUI and Cloud Hub. You have everything there. You don't need to take care about any Docker files or anything. Mulesoft to optimize all of this process for you. So even it has some sort of optimized image for runtime, Mule runtime for you. So you don't need to take care about any of this process. Everything is maintained by Runtime Fabric for yourself. You just need to deliver the functional aspect of your application at this point. And then you deploy your application through CI/CD process, for example, or Cloud Hub, whatever. Your process or Docker will push to repository. The repository for RTF will be Runtime Fabric Runtime Registry at this point. And then once it's pushed as a Docker image, it will be pushed to your cloud infrastructure target, for example, EKS at this point. We will practice all of this process later on. So in very high level, you don't care about anything. You just care about delivering your application as functional aspect. The Docker history, we know the Docker history. I don't want to talk about the Docker or Kubernetes a lot at this point, but Docker, the main idea of Docker is to ship your application as is. So if you have development environment, you run your application, you put everything in the Docker or the container, and then you ship it to production. And this is the target of Docker at this point. The next topic is RTF architecture. Since we deploy RTF as Kubernetes or by your Kubernetes cluster, we need to understand some basic component of Kubernetes. The first component, the most important component, is the node itself. So if we're talking about from AWS perspective, the nodes will present the node as AWS EC2 instance. So basically, the node is EC2 instance. Moving forward, what type of node we have in EKS? We have master node and we have worker node. The same concept we have in Cloud Hub, we have the control plane and runtime plane, but in EKS, we call it control plane and data plane. So don't be confused. There are different concepts, there is different terminology at this point, but the master and the node, master node is still node, but the master node has a different tent. Tent means it prevents to install any pod in the master node, because the master node is basically to monitor all of this worker node. So in very high level, we have master node and we have worker nodes. The master node has different components. We have etcd, scheduler, cluster component to make sure everything is up and running, and we have the worker node. Why we need to discover all of this stuff? Because it's very important to understand your deep architecture of your cluster, because RTF is installed inside your cluster. So basically, you need to understand all of components inside your cluster. So when you do sizing of Mulesoft application, you need to understand there are different application running side to side with your EC2 instance. So EC2 instance has scalability. Let's say you have EC2 instance with 2 vCore and 1 gigabyte of memory. You need to make sure this 2 vCore is not full capacity for yourself. Part of this 2 vCore, there are application running and occupy from this 2 vCore. So as you see here, the master node has different components. One of them is to make sure all of cluster component, all of cluster nodes is up and running. For example, here, example of we have application deployed to 3 nodes and one of nodes is down. So this type of control node make sure everything is up. So if you have a cluster with 3 nodes, 1 node is down, it will create and provision extra node for you. Who specifies the state in the Kubernetes cluster is a CM control. We don't need to know all of this, but it's very important to understand all this aspect of EKS cluster. Yeah, so let's say I have here the Cloud Hub. Cloud Hub deploy application to EKS cluster. How this happen? It's happened through the Kubernetes API. So basically, Cloud Hub created a deployment file for you and pushed the deployment file to Kubernetes API, and Kubernetes API takes this and which is the master node or the control plane and the provision the pods for you in worker nodes. So if we put everything together at this point, we have control plane, we have worker plane. Control plane contains, for now, four components. So if we move forward, we will have more details about every one of these. We talked about node previously. So here, the master node, we have the worker node. So now we will talk about the worker node itself. So each worker node has something called couplet. So couplet is maintain the state with the master node. So basically, I say we have 3 nodes here live, and this node contains the communication with the master node. Moving forward, we have more pods inside the node called proxy. The proxy communicate. So each node here communicates with each other through the proxy. So if we have 3 VM or 3 EC2 or 3 nodes, each node must have at least 2 pods, one called couplet. In EKS, it's called EWS node, and another one called kube proxy, which is key proxy. So if we put everything together, we have control plane of key EKS, and we have runtime plane, which is EC2 instance, and each EC2 instance contains 2 pods, one for couplet, one for key proxy. So why we talking about all of this very deep infrastructure of EKS? Because we need to understand what type of capability we are talking when we host our RTF inside the EKS cluster. And here's example what I mean by understanding the sizing and the capability of EKS cluster. Here the EKS cluster has the 3 nodes. The first node is T3 micro and T3 macro. So it's 2 different node groups. The first group contains two T3 micro. The second one is T3 small. And we need to understand how many of our application we can install in this node. So sizing your Mule application, it doesn't really going about the CPU limitation or memory limitation. It's also about the networking limitation. Each EC2 instance or each node in EWS has limit of how many network elastic network interface can be attached to this node. For example, here T3 micro can have maximum of 4 boards we can install in this node, regardless of the CPU or memory limitation here. So if we have T3 macro, each one will allocate 4 network, elastic network for each one. At the end, we have 8 boards we can install into this node group. Another one, we can install 11 application or 11 boards in this node group. If you remember, for each worker, we have 2 boards, one for the proxy and another one for EWS node to communicate with master. So in total, we have extra 6. And then we have DNS service. We'll talk about all of this later on. So if we do all of this calculation, if we have EKS cluster with 2 node group, with this type of structure, we have only 11 board, or we have only 11 application we can install in this type of infrastructure. And what if we're trying to deploy application with 12 replica set? The last one will not be installed because basically we don't have enough elastic network interface for this last one. So talking about the limitation, it's not only about the EC2 instance of the node limitation, also RTF comes with limitation. As you see here, there are the limitation for each RTF cluster. The maximum we can allocate is 30 nodes or 30 EC2 instance for the cluster. Then the node itself type must be EKS, not Fargate. I'm not going to talk about the difference between Fargate and EKS at this point. The replica per core is maximum 25 core replica. You will understand why all of this calculation later on. Up to 40 maximum per node. 50 maximum if environment, and 50 maximum of Runtime Fabric per business group. So what if you need more of this? You need to provision another RTF cluster. I don't think we will need more than 15 maximum environment for all of business group. But if we need, at this point, we can provision another cluster, provision another RTF. So what is the pod? So if we create application and then we push it to RTF, what is exactly inside this pod, and what is the limitation of this pod? As you see here, this is a real example of configuration deployed by Cloud Hub into RTF cluster. Each pod contains 2 containers. The first one called app. This contains our application itself, contains the runtime of Mulesoft, and contain your application as well. The second one is anypoint monitoring. The CPU of your application is between 20 micro CPU, milli CPU, to 50 milli vCore for sample application. This is the maximum you can do for sample. When we're talking about sample application, let's say you deploy Hello World application to Runtime Fabric, it can take between 20 millicore to 50 millicore. But regular application, it depends on your requirement. It can go up like 200, 300 millicore for your application. For the monitor container, it consumes 50 millicore. So why we need to talk about all of these numbers? Because we need to understand the footprint of each application. So when you do CPU, when you do sizing for your application, so let's say you have two EC2 instance or two nodes with two vCore, you need to understand there are some numbers need to be reserved in advance. Numbers goes to monitoring container, numbers goes to runtime itself, and then you add over this your application itself. There are also allocation for the memory, for the monitoring component, and for Mule application itself. Mule 4, for example, it consumes 700 as a minimum. For Mule 3, it's 500. The monitoring component here, or the monitoring container inside your pod, is responsible to push all of these statistics about your application. Let's say you want to monitor CPU memory of your application in RTF. Any point monitoring container is responsible to push all of these statistics to Cloud Hub, and you can see all of this stuff from there. So if we put everything together, if we deploy application, we said we have a couplet, we have key proxy, and we have something new here. It's called RTF agent. So after we install RTF, we'll have RTF agent. RTF agent is the main component responsible to sync everything with Cloud Hub. The RTF agent, as we said, the minimum CPU is consuming is 100 millicore and 200 megabytes for memory. There are another component maintaining the cluster state. It's called Mule Cluster IB Service. 50 millicore for CPU, 100 for memory. Another component for resource caching. So when you deploy stuff and you want to deploy it over, let's say 3, 4, 4, 5 replica, so this component maintain all of this resources caching. Consumption of a footprint of CPU is 100 millicore for CPU and 15 millicore for 50 megabytes for the memory. So all of this number is very important for you to understand. All of this number you need to reserve in advance before you install your application. As you see, we didn't deploy our application yet. All of this number need to be reserved in advance for you. And then there are another components called look forward. But look forward, it's I assume it's deprecated in last RTF version 1.10, but the previous version of 1.10, you can see look forward. Look forward, if you have, so basically as you see look forward, you can forward your logs to any log aggregator component like Splunk or ELK stack. If you have look forward in your RTF, it will consume 200 millicore from your EC2 instance and 200 megabytes for the memory. So at this point, we didn't install our application yet. So you need to make sure to calculate all of these numbers together, plus couplet, plus key proxy, give you the minimum requirement for your application, for your EC2 instance. So let's say you need at least half vCore per node to be in advance before you install or before you deploy your application. It's very important to understand your limitation before you do sizing of your application in RTF. Here's some statistics for performance and startup of RTF infrastructure. So if you assign for your application 70 millicore, this is 70 millicore, it can start up just 10 to 14 minutes. So this numbers, it's I think it's average, but you can reach less than this. I saw some examples I did earlier. I can reach less than this numbers. Again, here is some statistics for response time for different vCore and concurrent connections per vCore. Okay, so now we understand what type of component will be installed inside EKS cluster, what is the limitation, what is the resources for each component. Now we are ready to install our Runtime Fabric. The installation of Runtime Fabric, it is very simple. We will be leveraging RTFCTL, which is a command line component from Mulesoft. You just run this command and provision everything for you. We'll go over all these details later on. Let's move quickly. Deployment of any application, you can deploy your application from a Cloud Hub, or you can do it from CI/CD process, which is a regular process when we do all of our deployment. The only difference between the deployment we did earlier, like for example, if we have Cloud Hub 100% control plane and runtime plane, the deployment target here will be Cloud Hub. But if we do RTF cluster, you will choose different runtime fabric at this moment. We do this as well. So, okay, we deployed our application, everything's fine, but how everything will be look like inside the RTF itself? As we know, Mulesoft has API-led. API-led is we dividing the API layering into different categories, 3 categories. We have experience layer, process layer, and system layer. I'm not going to discuss the difference between them. Here example of, let's say, querying user from Salesforce. So we have system layer, which is basically communicating with downstream system. Is in this case, it's Salesforce. We have process layer. Let's say we do some orchestration or do some, all of this stuff before we querying the downstream system. And this is a real example how everything will be connected together in RTF. So when experience layer it invokes the process layer, for example, we invoke it through a service, which is a cluster IP. Cluster IP is a private IP inside the cluster. It's not accessible from the public internet. But if this means if we have API X and API Y here, we using the IP to access. Now we use a service name which is resolved by AKS DNS service. So basically, if we want to invoke the process layer from experience layer, we invoke it by using the service name of the API itself. The same here, process layer and system layer, we using the service name to invoke the downstream layer. The ingress component is something is not supported by RTF. RTF, it doesn't give you this type of it doesn't give this type of feature. What is the ingress? Is ingress meaning we want to enable external user to invoke our application. How we can do this? So we have something called in Kubernetes, something called ingress. So the ingress is a controller. We control the external traffic to come to our infrastructure, our microservices architecture here. RTF doesn't offer any ingress, so it's up to you. As we said, RTF in Kubernetes is a shared responsibility between Mulesoft and your infrastructure administrator. So your administrator needs to provision something in advance to enable the external user to consume your API. So it's up to you. You can provision. There are different types of ingress controller in the market. So you have Nginx, you have Kong ingress controller, you can use EWS ingress controller. You have different options in the market. We will discover later the difference between them. Today we will demonstrate Nginx ingress controller. As I said, it is outside of scope of RTF. RTF doesn't provision for your ingress controller. You need to do this in advance. So what is the ingress controller? It's basically we have load balancer. It can be application load balancer and or network load balancer. Again, there are different between them. Today we will demonstrate application load balancer to terminate TLS, and then from there, load balancer will balance the load between different nodes in the cluster, and each node has pods and all of this stuff we use in Cloud Hub. At this point, let's talk about the scalability point of view. When we talk about the scalability, which means how we can scale our application. Can we scale up? Can we scale down? How we can do this? And we'll ask ourselves some question. How RTF can scale application? Can we scale it dynamically? Can we scale it statically? What type of scalability we do at this point? Here is an example of RTF deployment from Cloud Hub. I tried to deploy an application called deploy demo it's called Maven deploy demo. So this is type of artifact or deployment generated from Cloud Hub. And here, for example, I decided to go with 2 replica. Replica means we need 2 applications or 2 pods hosted our application. So if one pod is down, another pod can serve the traffic. And then we have here some, each pod will contain 2 containers, as we said before. The first one will call app container, which will host our applications. Another one will be monitoring container to send all of the statistics to Cloud Hub. So, but how we can do this auto scaling feature? We know we understand there are horizontal pod auto scaler. What is the horizontal pod auto scaler? In very high level, if we have example like this one, so we have traffic come to our load balancer, and the load balancer route traffic internally to our application. Our application at this point, if you see, we have 2 applications or 2 pods for our application running. Everything is fine, but sometimes when we have more traffic like this, the CPU is going up for some of pods. So what will happen next if we have more traffic and more traffic? So we cannot accommodate all of this stuff unless we have more pods automatically provision in runtime. And that's what we call it horizontal pod autoscaler. Autoscaler means we can have this flexibility to provision pods automatically in runtime. This means we can autoscaling up only? No, we can do also down scale and up scale based on some policies. Let's say scale the CPU if the CPU of this pod more than 50, we can scale more pod. And then when the traffic go down again, let's say, okay, the traffic went down again, so we don't need this extra pod. So the horizontal pod scaler will kill this pod later on, and then we'll end up with 2 pods. And this is the idea of horizontal pod scaler. Unfortunately, horizontal pod scaler is not supported by RTF. I don't have the exact reason why it's not supported, but if you look here in this screenshot, in Cloud Hub, you can decide how many replica you can deploy in RTF. So at this moment, if you see, you can say, okay, I want 2 applications for this API to run, or 2 nodes or 2 pods to run for this application. So if one is down, another one will serve traffic. But why we don't have a horizontal pod scaler, I don't have exact reason for this, but we will experiment today horizontal pod scaler by ourselves and see how Cloud Hub will react to this if we do horizontal pod scaler by ourselves in the background. But RTF come with the concept of bursting. Bursting means in this screenshot, we say deploy this application into 2 pods, and the minimum core allocated is 500 millicore, yeah, which is half, let's say half vCore. And then we can set the burstable number, which is 1.7. What does it mean between 0.07 and 1.7? Which means if our application will have a lot of traffic, we can still go over, let's say, 0.5 until 1.7. We can use this limit to serve the traffic until everything go back to the normal. And this is something offered by RTF in place of HPA. So you still can use the CP bursting shares between all of application in the EC2 instance or the node itself. I think it is good option instead of HPA, but still you have a specific number of replica running all of time. But if you want to have some sort of scalability of HPA, we will do this. I will demonstrate this. I will tell you what is the risk behind HPA implementation in the background, and then you can take risk go with this or not. We talk about HPA. As we said, HPA is a scaling node around the, scaling pod in the node. But what if we reach number of pods per node? So let's say we have 2 nodes, and then we reach the number of the maximum number of pods for 2 nodes. If you remember, we have this exercise about number of pods, and we said the maximum number of pods, it will be 11. What if we need to provision more pods? We don't have this EC2 instance. Can we do EC2 scaling? With RTF, it's very difficult to do, but you can still automate this through manual scripting itself. Before we go there, what is the EC2 scaling? As we said, basically we need some sort of automatically scaling another node or EC2 node or EC2 instance in runtime. As I mentioned, we cannot do this with RTF automatically, but we still can do this through some sort of Ops Center scripts and manual script to add node to the cluster automatically in runtime. Yeah, this is all about the autoscaler. As you see, we discussed horizontal pod autoscaler, we discussed cluster autoscaler, and unfortunately, both of them is not 100% supported. But again, RTF gave us different options around CPU processing and all this good stuff. Another feature from Cloud Hub or Mulesoft is application clustering. The application clustering, please don't be confused between EKS cluster and application cluster. Mule runtime cluster is application type of cluster, which means if you have 3 pods, you can share the grid between them. You can share the status between them. So let's say we have request comes to our microservice, and for some reason this service is down or this pod is down. Can we still serve this traffic? Yes, we can do this through the cluster option of Mulesoft in RTF. I think this is very good feature from RTF because it solves a lot of issues around file-based connector. If you remember, if we have cron job and we have different worker, we have to flag the master node as a master node to process this type of files, because in Cloud Hub we don't have this type of cluster. Again, I don't want to spend more time talking about cluster here, but it is very good option here in RTF to enable cluster. In order to enable cluster, it's just one click here. Just click here to say I want to enable cluster between nodes in this EKS cluster. You don't care about the deep implementation of EKS cluster at this point. It is I think it's hazard cost in very low data, but again, it's not exposed to us how Mulesoft handle all this clustering between nodes in EKS. And really, you don't need to spend time trying to understand how it works at this moment. Logging and monitoring. In EKS, we have different logging. As we said in the beginning, we have control plane and we have runtime plane. Control plane has different components. As we said, each component generates different logs. Is this something we need to take care about? No, we don't care about all of this. We just care about our application logs and how we can view this application logs. In very high level, it's the most component we're dealing with. The application create logs and we push logs to to CloudWatch, and then we can stream it to Elasticsearch service. If you are lucky enough and are Titanium user of Cloud Hub, you can still see your logs in Cloud Hub. Unfortunately, my account is not Titanium, so I'm going to demonstrate today this use case in front of us by pushing logs of our application to CloudWatch, and then we will visualize this CloudWatch in Elasticsearch. Is this the best architecture we can achieve when we are dealing with logging and this type of non-functional requirement? No, I don't think so. But if we go back a little bit and talking about logging caveat, here is how the logging looks like inside our application in EKS cluster. As we said, the node is EC2 instance. Each node in AWS is basically attached to EPS. EPS, some sort of, let's say, hard disk attached to this. So if you kill this EC2 instance, all of your information will be terminated as well. So basically, we need to isolate, or we need to push this log somewhere into our infrastructure. So if we have different nodes, or we have different EC2 instances, if each node has different pods, so we need to have some sort of mechanism to push all of our logs to some sort of log aggregator. In very high level, this is how it's supposed to be looks like. So the application doesn't care about the logs itself, just generate the logs, and then we have some sort of component, we call it log forward or agent or whatever it's called, to push this to some sort of log aggregator component, like Splunk, like Elasticsearch, and CloudWatch. Sorry. Again, is this it will be the optimal solution? I think we can do better with more architecture implementation. I would prefer this type of streaming of logs. So let's say we have EKS cluster with 2 or 3 nodes. Each node will have FluentD. FluentD is type of log forward agent. You can install it in EKS cluster. So each node will have this type of agent to take the logs from our application, Mulesoft application, push it to Kinesis data firehose. What is the firehose? Is delivery service. The idea behind this is we can scale our logging later on. We can take the logs from here, push it to different log aggregator at the same time. We can take our logs and make some data analytics of these logs. We can do some machine learning for this. Let's say we are dealing with payment information or health information. We need to do some sort of machine learning over our transactions. We can push this to the Kinesis, and Kinesis will push it to, let's say, to Kinesis data analytics, do some analytics, and then we take it from there. So this type of architecture I'm really like to do in real life, but it's up to you. It can cost you. The more components you add to your architecture, it can cost you. But as you see, it's more elastic. It's more loosely coupled. You can integrate any logging aggregator component in future with no or zero change in your infrastructure. The monitoring component is out of box of RTF. So if you remember, we said we have each pod installed in EKS will have 2 containers, one for our application itself, another one for the monitor. And this is the information comes by monitoring container. So everything in this pod will come to Anypoint monitoring in Anypoint platform. So you can monitor, you can put your rules, you can move your alert, you can do everything from Cloud Hub here. The last topic here is the security. Before we do the demo, there are different type of or different layering of the security. There are infrastructure security and application security. As we said, we deploying our application in EKS, which means it's shared responsibility between the administrator and the application architecture. Mule Runtime Fabric itself. If we divide this, we can say Anypoint platform as a control plane will handle all of this type of security concern or security layer. We have API management to enforce security over our API. It's still managed by RTF, Anypoint platform. We have tokenization service also is offered by Anypoint security module of Anypoint platform. We know that tokenization service basically if you want to mask important information like let's say credit card or personal health information, we can use tokenization service to mask all of this information. Everything here is out of box from RTF. From an infrastructure security point of view, we will demo Nginx ingress controller security. It's different type of security. As we said, it's shared responsibility. You can implement security at different level, at the infrastructure level or outside traffic or inside traffic. We'll talk about this in the demo as well. The last topic is the persistent gateway. What the persistent gateway is basically the object store. Can we, if you remember in Cloud Hub, we have object store version 1, version 2, and all the stuff. But can we do this still in RTF? Yes, we can do persistent store. The persistent store itself or persistent gateway itself, it's based on Postgres SQL. So you need to provision in advance Postgres SQL. And then you can configure the gateway using this Postgres. in RTF. So the only requested at this point is provisioning PostgreSQL, and then you can use the persistent gateway. So if I'm developer, how I will use persistent gateway? You don't need to do anything. You just still you can use Object Store version 2 to utilize your Object Store. You don't need to change anything in your application. You still need to use Object Store version 2 to utilize Object Store or Data Object Store. Yeah, so let's go ahead with demo because I'm afraid we'll not have much time. The demo today, we will for sure. I would like to provision the cluster in front of you, but the cluster can take up to 15 minutes. So I did this in advance on some extra component. I will walk you through everything now. The demo today, we have 3 availability zones, 3 subnets. Or 6 subnets, sorry, 3 in the public subnet and 3 in the private subnet. Our application, our Mule application will be installed or be deployed in the private subnets, which means it cannot be accessible from public internet. As you remember, we said we will have ingress controller to access our APIs, and this is the only gateway to access our APIs through the ingress controller. We will manage our runtime plane, which is EKS runtime plane from Cloud Hub control plane. So let me just bring the another. So I will divide. I hope you still can see the small screen
yes,
here.
you can see, Basim.
Yeah. Okay, so let's start one and see what we're talking about here. So everything is committed to GitHub. I commit everything for you here. So in order to start with EKS cluster, as I said, I already provisioned the cluster for you. I'm using Terraform to provision the cluster. The VPC, as I said, it's 3 subnet in the public. As you see here.
Do we have the steps as well? I mean, the initial step for installation, or we can.
Sorry, which one?
The RTF installation steps.
Yeah, the RTF installation step is required after we understand what type of EKS cluster. As we said, it is shared responsibility. Before you install RTF, you must install your cluster. Yeah, so that's why I'm just giving highlight what is the cluster looks like at this point and how I provision that. Yeah, so yeah, so everything here is in Terraform format. 3 subnets in public, 3 subnets in private. The VPC is configured for you. The Kubernetes here is, as I said, it's 2 groups, as we discussed in this slides. Everything is out. So what you need to do is to come here, export some information here, and then you start to run Terraform apply for you. Once it's done, just make sure the kubeconfig is up and running for you. Make sure you can kubectl your cluster and everything is good. The third component we need to discuss is a metric server. The metric server is required for HPA. As we said, we will experiment HPA, horizontal boot autoscaler, by ourselves. We said HPA is not supported by Cloud Hub, so we will do some experiment on our own risk to see how the Cloud Hub will react to horizontal boot autoscaler. In order to run horizontal autoscaler, we need the metric server. The metric server is aggregator component. So it constructs for us some metric. We can use, let's say, CPU usage, memory usage, and then we can scale our application based on this metric server. So I installed the metric server as well. So let's go here to EKS cluster. So I have the cluster here. The workload, as we said, We have the matrix server. It's responsible for HPA. We show how we can provision this. We agreed we have EWS node. If you remember, it's responsible to communicate with the master. We have 3, which means we have 3 EC2 instance, 3 nodes or 2 globs. Each one is 2, 1, 1. That's why you have 3. Proxy will be 3 as well, as you see here, which makes sense. As we said, each node will have its own board. And then we have Nginx controller. So let's go back here. And we have look forward. We install Fluentd look forward. This is how we can do this. I don't want to spend more time to explain the stuff inside, for example, so Fluentd, how it looks like. I give you everything. It's more configuration here. Just make sure you export everything in advance, and then everything will be running smoothly for you. Once you install Fluentd, it will install Fluentd for you. As you see, its number is 3, which means we have 3 EC2 instance nodes. Okay, this number makes sense now. Let's go back. So we install look forward. We install EWS Elasticsearch as well using this command. I did all of this because it really consumed time from us. Nginx controller, again, I install Nginx ingress controller with application load balancer. So the end of this process, if we go to EC2 instance here, and then we go to load balancer, we'll see our Elastic load balancer here, and then we have different, we have 443, we have SSL certificate as well generated for us. So everything, it's good. I configured everything in advance. But again, if you follow this, you should have everything up until for you. So let's start by the most important one, is the install RTF. As I said, installation shouldn't take much time. So the first step is to come here to RTF. Let me just erase this. So I'm going to Runtime Manager. So I don't have any Runtime Fabric at the moment. So the first step you do is just do some stuff. So okay, this is my AWS infrastructure, and even if you do with bare metal, you can still do it from here. So everything, it's really nothing you can be worried about. So you just put there and then next, and then tell you this is shared responsibility. As we keep saying this, RTF, it's shared responsibility, so you need to make sure you provision your Kubernetes cluster in advance. You understand your Kubernetes cluster before you provision anything. And then you would say accept. It gives you the installation key. We just copy this, and then let's run the terminal here. Yeah, I'll have some time to. So the first, so let's go back to installation steps. The first step is to validate. Meaning of validate is RTSTL. As I said, RTSTL is the command line. You need to download it from Mulesoft. It's basically you can find it under GitHub as well, so you don't need to worry about it. So you just not validate, and then you paste this key generated from CloudHub. So as you see, the validation step, it's basically it go over the EKS cluster, make sure everything is good, the memory, CPU allocation, make checks as you see green, provision something for you in the EKS cluster, and once it's done, it tell you, okay, it's good to go, and you can now install your RTF. The next step is basically to install your RTSTL, and then you say install the same key, and then unfortunately, you sometimes if you install RTF many times, it have some problems. That's why I'm using this force reinstall, because I install it. Sorry. Sorry, this. So that's all you need to do at this moment. So what will happen if we go to our cluster here? Let's go to our EKS cluster. And then if we go to our workload, you can see there is a new namespace called RTF. And it will make sense for you. You see agent, and you will understand the agent now and what is the consumption of memory and CPU for the agent, understand what's the responsibility of agent. We saw before Mule cluster IP, we saw before resource caching. I think if you look here, you can understand each component and what is required usage resources for each one here. So we just need to wait until everything. So as you see, it's started to provision the RTF agent and resources. Can come back to here, just wait. So it's ready. So I said RTF is good. So while we're waiting for this, let's go ahead with the license. So basically, we need license for Mule application. The same like we have on-prem, we need license to run our Mule application. This is valid license for 1 month. You can still use it for some days. I'm not sure how long it will be, but you can still use this. So basically, I'm informing the RTF installation in EKS that to use any Mule application will be deployed to use this license. If you don't install the license and you're trying to deploy application in EKS, it will be failed because application needs a license. So let's go back here. Runtime. Okay. Still coming. Okay, that now it's active. So everything is good. We didn't do anything. We just run a couple of commands and everything is up and running for us. The second step is just to associate the environment. What type of environment you will be associated with this Runtime Fabric? Today we took our sandbox environment, so just need to apply. You can also attach this to specific business group. As we said, each RTF installation will come with some limitation, number of business groups, number of environment. You're already aware about all of this stuff. The inbound traffic, which is the ingress controller. Yeah, we talk about the ingress controller. We already agree RTF is not type of component will give will provision the ingress controller for us. So we need to make sure ingress controller is up and running before we run our application. Otherwise, we can deploy our application, but we will not able to invoke our application since we don't have any inbound traffic controller. Okay, so let's start with deploying the first application. So let's deploy a first application. I'll go back. Just go application. For sure, in real life production environment, we don't do stuff manually. We have CI/CD process. So let's say install first application. And then you select your deployment target, and then you select your application. I already push it to okay. Okay, that's unexpected. Okay, going to back to my Exchange. I don't see my application, that's why it's here. Okay, go back to my Runtime Manager. Then the application, sandbox, RTF. That's weird. I don't have the application jar itself, that's why I know I installed it here. Okay, that's unexpected. Sorry. So let me go back to Exchange just to make sure the application is good. Okay. My temp. Time manager. Okay, so for some reason it's what I
Hi, Bassem, it's Kevin. Why are you selecting example from? Is it not an application? I think you can't.
it's application, yeah.
So try checking the application type application. Can you not find it now? Is it not?
It's example application. That's how this is. Yeah, I can push it again to Cloud Hub. That's not a problem. So this here I'm sure it was there, but must be somebody make something. So I'm going to publish to Exchange. Okay. Okay, F, it's example application, everything's fine. Temp. Okay. Sorry for this. I'm sure it was there. Must be somebody cleaned up.
That's
like
okay,
Bassem. Yeah, usually I don't like to upload jars and stuff. I like to go with the normal process, having the assets in the Exchange and continue from there.
Yeah. True. So meanwhile, it's uploading. Maybe if there are any questions, we can take that up. And Basim, also someone has asked to share the GitHub link. Maybe we can share it later.
Yeah, sure.
Yeah.
Okay, so it's there now, which is good. We select. Okay, let's go here and say. Okay, just make sure the ingress controller. Yeah, before we deploy application, we need to make sure the ingress controller is configured. As I said, it's unless if you deploy your application now, you will not be able to invoke your application from external. So we need to configure the ingress controller for our application. Yeah. So the first step, let me close this one. And let's explain something here for ingress controller, Nginx controller. This is the ingress controller expected by Runtime Fabric. It is some sort of a template, as you see here. We prefix the templates with RTF. I'm not going to go over the structure, but in very high level, we associate this with business group. We don't need to write anything, as you said. We just tell RTF, when you install any application, make sure to append the business group, to append the environment, and I give it to you. So I prefix this with RTF. So when you install, grab this template, and then you configure your ingress controller based on this template. Yeah. So we need to install this ingress template before we install our application. So I'm going to copy this one, and then so here is the ingress controller is created for us. At this moment, we can install our application. So let's go before we install application, just to make sure the controller. See, so once we install our ingress controller, it will become like a template here. So this is the template for all of Runtime Fabric. So if we install application X, it will be x-dev-api camp. If we install Y, it will be replace app name with your application name. So let's go back here and then deploy again. Then hello RTF. Select our deployment, import it from RTF, Exchange 3, then select. And then we say the replica now, we just need one application for now. And then the reserved CPU is 20 millicore, burstable up to 1.9. As we said, this is the maximum we can leverage for this application, which means if we have thousands of transactions coming now, we can go up from 20 millicore up to 1.5, 1.9 vCore. So we can deploy our application. So while it's deploying here, for sure our application will be failed for some reason. But let's see why it will fail, which is good point to see the CloudWatch stuff and the logging view of logs. If you remember, we install our log forward agent, which is FluentD. FluentD is agent installed in each EC2 instance to push the logs to CloudWatch. So if I go to CloudWatch here, we will find a log group for our RTF cluster. So as you see here, there is logs coming from our application here. We can see logs from here, but as you see, it's not this friendly logs because it's coming from the container and all this stuff. Here I configure a subscription filter, which is we take our logs, we push it to Elasticsearch by using Lambda function. I'm not going to discuss a lot of this stuff for now. So let me go to Elasticsearch here. Then if you go here on the main, then Cortana, then if we, so I don't have dashboarding here. I just want to show you how the logs will be ended up. You can filter, you can aggregate the logs, and everything is good here. Again, I know why it will be filled. So if you go back here, we still trying to fill the application because we have we are linking this application to API manager. So basically, we need to make sure the API manager proxy for this API ID. We call it API ID. So if we come here, let's create API from this one. So yeah, so it's coming from Exchange as well. So it's Mule 4, everything's good. Just save, and then it gives us an API ID. I'm not sure if most of you are aware about the link between API Manager and Runtime, our application. But basically, if we need to manage and secure our application using API Manager will create for us API ID, which can be linked with our application. That's why our application is is failing to run because this ID is required. So let's copy this one. Let's go to our application again in runtime. And then I go to properties and just try to insert some values here. The first one is the application ID. It's required for application. Second one is the client ID for any point. This information we needed part of deployment as well. So we need to go back to our environment, which is the sandbox. Sorry. Environment and then sandbox. I know you can see the stuff. I will remove all of this stuff once you finish. Just copy the environment information, then come here, client ID, client secret, then apply changes. So what we do here is we link our API with the API manager, so we can enforce some sort of policy over our API in runtime. So let's wait and see. Also, if you don't want to wait here, you can go here. You will notice here. So let's take a look here while this application is trying to deploy. Go to workload. You will notice there are new namespaces called something like this. What is this new space? This is our environment ID. So if we are in any point, we are deploying from a sandbox in this business group. So any point of the platform, it takes the ID of the sandbox, generate or create namespace in EKS using this ID and try to deploy this application inside this namespace. So if you have the same application in production, it will have different namespace for the production. So you don't have this, you have this type of separation between environment using namespace in Kubernetes. So it's, see? Okay, that's good. That's good news. So if you see here the application, if you remember, we tried to deploy application in one bot or one replica set. So everything is good. It's one ready, and this is one desire. We desired one, so everything is up and running for us. So if we go back, we must see it's good. So our application now is up and running. If you go to ingress case, you will see it replaced the app name. I know I'm going back and forth, but we must do something like this to show you how everything is linked together. If you remember, we said the template will be app name dash the domain name. So we ask the RTF to replace app name with the application we're trying to deploy. We try to deploy hello RTF. So it take hello RTF, replace app name, and at the end give us the ingress to invoke this API. So if you want to invoke this API, you must go through this endpoint. So let's see if everything is good. I have here Postman, this very basic stuff. Again, I have Route 53 and the ECM. I have certificate. I have TLS termination. There are a lot of stuff here, but it's a lot of details. If you guys need more information about termination of TLS, application load balancer, Route 53, and everything, how it linked together, we can continue after the meetup. But for now, I can invoke the API through the ingress controller. The API has different endpoints, as you see here. It's good. So we deployed our application. We didn't do anything, just deploy, configure the ingress resources. We bought some resources, and we know the all of logs of all of containers, it will go to CloudWatch. So again, if you go to our application, deploy it. If you remember, we said each application will have two containers. The first container will call app. The second container will call any point monitoring. If you open any one, for example, the app one, you will see the CPU limitation and memory limitation for our container. Logs will be pushed to CloudWatch. CloudWatch will push to LKStack. This is the traditional logging aggregation happening in the market. But as I said, there are different enhanced architecture of this type of data engineering in real time. Okay, so let's experiment some stuff here. So let's go back here. We said we have different type of ingress controller in the market, and I choose today Nginx controller. Nginx controller has different annotation we can leverage. For example, you can limit how many requests per minute coming to your infrastructure. Again, this is different level of security. You can enforce security, resource per minute, or rate limiting using API manager of RTF. Yes, but there are also another security layer, which is in ingress layer. So you can limit resource per minute in ingress layer. So before the request will come to the container, and then the API manager will decide if we allow him or not, we can enforce the security at the ingress layer. So let's go back a little bit with this stuff here. So we said we have the ingress controller, we have our bots. So there are two different layers of security here. We can enforce the security layer at the ingress rule here, or ingress layer, or we can enforce the security at the pod level. What we see right now is we enforce the security at the ingress rule. So instead of we are waiting until the request come to our pod and see if we can allow him or not, we can enforce at this layer. If you don't want to enforce at this layer, you can enforce by API manager at this layer. Today we will talk about both cases here. The first case is enforcing at the ingress layer. As you see, we have annotation here. It's called limit resource per limit. This means we cannot invoke the API more than 5 requests per minute. Yeah. So let's experiment this. So that's what I do. I'm just coming here and then I say run collection. I just don't need all of this. Let's say then run 30 times. So after some time, it says 543. This is the expected behavior from Nginx controller to react to resource per minute. So let's say you already reach your quota at this time, and we cannot serve you more than 5 requests per minute. So anytime you invoke the service, it will give you 503 until the second minute come, and then it starts to recount again. Is this the only thing we can do with Nginx controller? No, there are a lot of stuff, really good stuff from Nginx. I would recommend you to, if you decide to go with Nginx controller, to go ahead with user guide, and then you have configuration annotation. They have really, very rich annotation. You can even have some sort of what we call it, canary deployment. If you have two different type of version of the application, you want to route the transaction to version 1, 50%, version 2, 50%, you can do this type of annotation. As you see, there are a lot of rich security enforcement at the ingress layer at this moment. So you can use Nginx controller. I see it's a lot of stuff, but some people, again, or some enterprise, they say, no, we don't need to enforce security at this level. We can enforce security at the pod level. Again, it's up to you as administrator talking with your infrastructure to enforce at which level. But I prefer to enforce security before the transaction come to us and utilize our resources internally. So yes, we showcase of this one. So we understand Nginx controller. The second use case I would like to demonstrate is enforcing security at the pod level. So let's talk about this, how we can enforce security at the pod level. So the endpoint will help us to achieve this through the API manager. So if you go to API manager, you see the status is active. Why is the status is active? Because we link our application, we deployed in RTF with the same ID. So the API manager understands there is application deployed in RTF, leveraging this API security. So what we can do here, we can enforce a lot of security. As you see, we can see also some monitoring, how many requests, how many files. As you see here is some sort of statistics, the failed statistics, HTTP responses, monitoring of our API. So let's try to enforce some policy at this point. So here, let's say some sort of basic authentication policy. And then let's say a username, let's say XYZ. So I'm asking the API manager to enforce this basic authentication to Hello RTF application. So any consumer trying to consume this API, it will reject him unless he provides this authentication. So let's go here and then try to send. So it's still trying to enforce this. If you would like to understand how the enforcement happened, so basically, while we are waiting for this, what happened at this moment? We enforce security here. What happened? Our Mule application runtime will try to fetch all of this policy from control plane and then try to apply this in the runtime. And this is what we're trying to wait for here. So we're waiting until the runtime, our application, our container, trying to fetch all of this configuration from control plane, apply it to runtime plane for this application. So as you see here, application said it's missing some basic authentication for this, since we enforce this type of policy. So if you go back, we demonstrate enforcing security or enforcement at least rate per limit at ingress control level. We enforce security or policy at the pod level. So I think we covered a lot from the security perspective. If you want to enforce more security, some users say, okay, I want to enforce authentication at ingress level. I included some configuration here as well. You can go ahead and try it by yourself. You can enforce authentication at the ingress level. There are a lot of stuff. You can play with all of this stuff yourself. So we cover the security. I'm not sure if we have much time. The last topic I would like to discover is the HPA, as I promised you. If we go back to our application, so let's before we go ahead, just let's remove this stuff. So if we go to our application, I'm sorry, not application manager, runtime manager. We all understand the auto-scaling feature. Auto-scaling feature is automatically scale number of replica based in the load on our application. But as you see here, it's number of replicas is static. We don't have this type of flexibility. We say, okay, increase if the CPU more than this or more than this. So what we can do, if you remember, we said we have our cluster, we install the metric server. The metric server is aggregator for resource usage in our EKS cluster. So let's try to deploy HPA policy and see how it will behave to our application. So here is the HPA policy. We said if the application reaches 75 utilization and CPU utilization 75, you can scale up to 5 maximum replica. Yeah, and then once the traffic is going down, you can scale down until you reach the minimum replica again. So this type of policy, it can help us to with this budget, because we don't need to have 5 replica running all of time, or we don't need to have 2 replica running all of time, because it costs us money. Because something running, this means CPU is running, memory is running, which means AWS will charge us for all of these resources. So what we do here, let's try to install the HPA. So what we do here, let's go back to our documentation and try to find the HPA. Okay, so let's export some information before. As you see, exporting information, I made the HPA is dynamic, which is relying on some information. So you can invoke the deployment with a variable. So I export, which application name is required, and then we need the default namespace. Let's go default namespace. Default namespace. Okay. Sorry, this one. If you remember default namespace, it will be your environment ID. So if you deploy sandbox, it will be your sandbox ID. Production, it will be production ID. Okay, we are good. And then we say set our. Okay. So let's deploy our HPA. Okay. Okay, so what happened here? It said it's the HPA is created for our application. So let's try to retrieve the HPA, see how it looks like. So until now, it says hello RTS application. We don't know exactly what is CPU and what is the memory. We know what is the minimum you would like to replicate. We know what the maximum, but we're still trying to get this information for you. So let's wait. Okay, so it tells you this application it's delivering 90% of 75, which means now it's time to go up with your application to deploy another bot. So let's see if so. If you look here, it started to increase more replica to your cluster. So if we go here, sorry, if you go here, we say this one. See, let's see what will happen in Runtime Fabric. And this is under your risk, because as I said, it's Runtime Fabric doesn't support HPA. It can still see the number of replica in dynamic way, but still tell you it is one, because when you deploy one. But Runtime Fabric has some sort of confusion. How come I deploy one, but you have two? That's why I'm telling you do this under your risk. But still it's running. Still you can put your policy. You can scale your application. You can have different scaling metrics based on HPA. HPA is a component you need to understand HPA. Your administrator, I'm sure he must understand what is HPA, what is policy. I just wanted to show you a case here. What happens if you try to enforce HPA policy behind the Runtime Fabric, and what will happen? And this is what will happen in your screen. Is this something bad or good? Again, it depends on you. I don't think it's bad. It's confusing for RTF, but still for our enterprise or your enterprise, you try to save money by scaling down your application or scaling up when you need more traffic. Again, let's watch. I see it's going up because it sees the application it's utilizing. After some time, there are some type of algorithm for HPA. It will scaling down your application once everything is good to go. The reason behind this, because I deployed with 20 millicore. 20 millicore is very, very small. If you go up a little bit, you will not have this number of replica in front of you. So this is what I promised you to show you the HPA capability. As a cluster autoscaler, I cannot show you because basically you can do this with manual script, but if you want something, I can show you. And this is the final output from HPA. It tells you 4 out of 1. So I'm not going to explain for you what is the one for. Again, it's one of your deployment here, which has nothing to do with 4. The last showcase I would like to do is enforcing runtime resource per minute. I think we did already this one, which is trying to invoke ingress control with main request, which is good. The last one is the data engineering. It's more like I prefer this type of data engineering, if you have some sort of data engineering of your enterprise. This is some architecture I would like to do in real life. Instead of having our application to push stuff to CloudWatch and CloudWatch to Elasticsearch, I would prefer some sort of more abstraction. So when your application is up and running, we push something to stream, to delivery stream. And from delivery stream, we can analyze this. We do this to machine learning. Let's say today we have data analytics, tomorrow we have S3, we have Blue services, Athena. So this type of architecture is more abstract and it's more flexible, more elastic for a lot of enterprise to implement. It's costly, but at the end, it's some sort of elastic for you to move forward. If today you decide to go with ELK, tomorrow if you decide to go with Athena and this or machine learning, if you decide after tomorrow is go to Kinesis, you still can do this type of architecture without zero change to your cluster. Yeah, I think it's I covered a lot of stuff. Good. So the last step is to make sure to destroy your application. I listed here a lot of commands. Batch the ingress. So if you want to increase number of resources per minute and see what is the behavior, I listed a lot of commands here. The last one is to uninstall the RTF. Uninstalling RTF, it's basically one command. I'm not sure if you guys will have question related to RTF before I remove it. So I will leave everything just in case if we have a special question related to RTF, but make sure to remove everything from your infrastructure, especially AKS. It costs you per hour. Again, we installed a lot of stuff here, so it will cost us as well. So that's all for me, Akshata.
Thanks, Bassem. Yeah. Sure, I'll just start sharing my screen. We can stop sharing. If you can just stop sharing. If there are any questions, guys, let us know. Y'all can just unmute yourself or type in the chat section as well. Yeah, sure. So the next one being the trivia questions. I mean, we'll have 3 trivia questions and 3 winners. So y'all can just answer the questions in the chat section, and then we'll pick up the first 5 guys, and then we'll have a random name picker thing. Okay. So the first question: what is the maximum number of replicas that can be deployed per node in RTF? Y'all can just answer in the chat, and we'll just take it from there. I guess we have first 5. Okay. So is it done? Maybe I can just tell you guys the correct answer. Okay, fine. The correct one was 40, the last one. So yeah, let's just start with the second question. How to use persistent gateway in a Mule application deployed on an RTF? And these are the 4 options. Okay, we have quite a few answers. Anyone else?
That's weird. We don't have anything for Anypoint Object Store version 2. So I said that we don't require from the developer to do any change in his code to invoke Object Store. So it will be follow the same way he used to do with Object Store version 2. So the answer is A.
A. Yeah. And that is none, right? None of them is answering. Okay. That's strange. So we'll just skip the second one. You can have the third one. So what's the CPU and memory footprints for monitoring container? Okay. The answer is, anyone else would like to try? Fine. The answer is C. And with this, I'll just list down the names and we can have the trivia quiz thing. Just allow me some time, please. Meanwhile, if there are any questions and all, you can just ask Basim. So for the first one, I'm considering Brittany, Sanjukta, and Ivan. Yeah, I hope you all can see my screen. So. Okay. Congrats, Brittany. Maybe anyone can take a screenshot or something. And also, Brittany, just share your details with me, the email address and your contact details, the LinkedIn profile as well. For the second one, correct answer was, yeah, we didn't get any correct answers. Sorry, the second one. And for the third one, we have the answer is C, 50M CPU and 50M. Okay. So from here it starts. It's Vinod Kumar, Joydeep, and Carolina. I hope that's all. Is there anyone else? Vinod, Joydeep, Carolina. Yeah, see. Oh, it's Vinod. Congratulations, Vinod. All right. That's it then. For the next meetup, maybe you all can just nominate yourself as a speaker, or if you will have some topics to suggest, you can just feel free to do that. And also, you'll be getting a feedback form post this session. So yeah, do fill out the feedback form as well. And yeah, you all can just share, maybe tweet about the meetup, the feedbacks and stuff using the hashtag Mulesoft Meetups. And also, you all can tweet us or Mulesoft, MuleDev, can just tag us. And yeah, that's it. Apart from this, if you all want, we can just turn on the camera and that should be it. We can just have some fun time in the networking sessions. Thanks a lot, Basim, for sharing all the information. It was really helpful. Also, if anyone wants to nominate yourself for the next meetup, feel free to do that. Vinod and Carolina, please share the information, the email address and details with us. Okay. I'll just stop the recording.